let's review how to write a program in Circom. You saw in the previous section that Circom program starts with pragma Circom and the Circom, and it continues with the Circom version, which is in our case 206 : To start execution, an initial component must be specified. By default, the name of this component is main, and only one main component can be defined. We type component main. The main component needs to be instantiated with a template. Templates are the mechanism for creating generic circuits in Circom. They define circuits and their own signals, such as input and output. For instance, template Fibonacci and then here Fibonacci. During compile time, the function argument should be known. Therefore, here I put 1000 and semicolon. Now let's look at inside our Fibonacci template. The arithmetic circuits built using Circom operate on signals. The signals are named with an identifier and declared using keyword signal. Also can be defined as an input or output. For instance, signal input Fib1, signal input Fib2, and signal output Fibn. Remember, signals which are not defined as input or output are considered intermediate signal, like signal C. Here is a list of reserved keywords in Circom that you should not use them as your signal name. Signals in Circom can be either private or public. From the programmer's perspective, only public input and output signals are visible from outside of a circuit, while private input and intermediate signals cannot be accessed externally. By default, the input signals of the main components are private, unless specified as public using the keyword public, like this one. Component main public Fib1, Fib2 equal Fibonacci 1000. In the previous version of our main component, Fib1 and Fib2 were private signals and Fibn was a public signal. In this version of our main component, Fib1 and Fib2 and Fibn are all public signals. This was an example. I go back to our original main component. All output signals of the main component are public and cannot be made private. Also, any other signals within the circuit are private and cannot be made public. Now, let's consider another example. I define another template here. I define it as template Fib template 2 and then write signal TMP. Now I go to my Fibonacci template and use the first template. I type component Fib, for example, temp1 equal Fib template 2, then Fib temp1.tmp is, I assign it to, for example, Fib1. I save this program as Fibonacci 2.circom. Now I go here and compile the code. I type circom Fibonacci 2 Circom -r1cs -wasm. As you see, compiler showed us an error. The problem is we are working with an intermediate signal which is not input or output. Therefore, it's private and we cannot access it from another template. The solution is very simple. For example, we put signal input, save it, and then run the command again. As you see, it's successfully compiled because now Fibonacci template can access the signal in another template because it's defined as input. Apart from signals, Circom also uses variables. Variables are identifiers that store non-signal data and are mutable. They are declared using the keyword var. Variables can contain either numerical values or the field or arithmetic expressions, particularly when used to build constraints. Let's define a variable here. I removed our previous example and start writing the code with our variables. Variable A equal fib1, variable B equal to fib2, and variable C. Now I compute the Fibonacci sequence. Let's put a comment here. Fibonacci sequence. I write a loop for I from here. I have fib1 and fib2. Therefore, I start from 2, I less than n, I plus plus, C equal A plus B, A and then B. Now let's discuss the signal assignment operation. Signals can only be assigned using let's double dash or let's double equal. The safer option is the second one because not only it assigns the value but also it generates a constraint at the same time. I set the output something like fib n equal to C times fib1. I save and then compile the code and it works fine. Now let's talk about functions. In Circom, functions perform computations and return values or expressions. They cannot declare signals or generate constraints. Use template for these purposes. Every function must end with at least one return statement. Here I define function func1 with 3 arguments n, a and b. Now I can simply move part of my Fibonacci code to this section. Return the result, then return C. And then here I replace C with func1 fib1 and fib1 and fib2. Now we are going to quickly go over the types of expressions in Circom. First, constant values. These are simply fixed numbers like 5 or 7. Next, linear expressions. These are sums of variables and constants like 5 times fib1 plus 7 times fib2 plus 12. The third one is quadratic expressions. These are formed by multiplying 2 linear expressions. For example, the first expression is this one, 5 times fib1 plus 7 times fib2 plus 12, and the second expression is this one. Finally, non-quadratic expressions. This category includes any expressions that do not fit into the previous ones. For example, I put the previous expression, a quadratic expression, and times fib1. Remember, in Circom, only quadratic expressions are allowed in constraints. So if I make this line a non-quadratic expression, I will get a compiler error. I save this one and then go to the compiler. As you see, I got this error from the compiler. Non-quadratic constraints are not allowed. Now let's review noun and unnown expressions. In Circom, constant values and template parameters, this one here, are always considered noun, while signals are unknown. An expression is classified as noun if it depends only on noun values, but as unknown if it involves any unknowns. For example, when accessing an array element in a constraint, the index must be a noun value. For example, here I define an array called CArray, the size of n, and n is noun in this function, and then I type CArray 0, for example, fib1, and CArray1, fib2. Now let's save and compile the code. Standard constructions are essential for defining the control flow within a program. Here I have already shown you the for loop statement. Now I'm going to show you the while loop statement and if then else conditional statements. So I comment these for and start writing the same logic with while. Now I want to put this inside a if then statements. If n equal 1, then c equal b. Otherwise, if n equal 2, then c equal b. Otherwise, the while loop. Save and compile. Before finishing this part and going to the next example, the last topic to review is the include command. To incorporate code from other files into a Circom program, the keyword include is used, followed by the corresponding name of the file. It is important to note that the .circom extension is assumed by default when specifying file names. So I write here include inc1 .circom column and then move my code, this part, to inc1.circom. Then I go back here, save, then compile the code. Coming up in our next video, we will dive into another example by showing you how to write a pseudocode program in Circom. Also, we will cover more features and details about the Circom language. Stay tuned.